Hello, my friends. How you doing? Welcome to the training on computer science. We're going to start the morning here taking a look at why we need to consider implementing and infusing computer science into all that we teach. Now, we know that the school day is already jam packed with so much curriculum and so many things that we must do in education. And so I know as you hear these ideas of one more thing, it becomes very, very hard to swallow this pill. But we have to remember this is not one more thing. We are looking at ways to infuse computer science into what you're already doing. And the byproduct of this is not more work, it's actually an increase in engagement, in creativity, critical thinking, problem solving, and collaboration. And aren't these the things that we're trying to figure out how to do more and more of in a classroom? So let's dive into this because what we're really after as we think about the present as well as the future is how do we help our students and our community and our citizens be less artificial and more intelligent? Because if we don't, then humans are going to need not apply because we're going to be replaced. I want to start off by thinking about this idea here that we don't need more computer scientists. We're not teaching computer science. We have more computer scientists in the world. Just like we don't teach math, so we have more mathematicians. Just like we don't teach literacy, so we have more novel writers. What we're doing is creating well rounded, robust, thought provokers, idea developers, and problem solvers. And computer science allows us to add some more skills and tools and ways to process the world around us. And so, what we're looking for here is not that we need more computer scientists, but we need more people involved in industries in the workforce with a computer science mindset. Computer science is infused in everything that we do, every single element. I bet today computer science has impacted several different factors of your life just getting here to the workshop today. So let's start on a fist to five. You've probably done this before in some shape or form, but I am curious to get a pulse of the room of where we're at so we can kind of set the stage for what our workshop's going to be for the next day or two. We're going to start here at a level zero. We're not doing anything in computer science. A one, their district wants to integrate computer science, but we don't know how. A two, our district's trying to integrate CS, and we can scale that as you can read. They're all the way to five. Like we are already interweaving computer science. Kind of this idea of like, why am I even here? You should be the one running the show, right? So let's consider where you are, and just in a general sense, and let's go ahead and show that so we can kind of see where we are for people to understand that for the most part, most of us are in the same boat, and it's okay. I like to tell people, computer science, we are really in the wild, wild west, this new frontier of thinking about education, what's important, how do we make it practical for kids, how do we help develop the confidence and mindsets while also not having to cut other things that are really important in the school day. We know that the struggle is real. There's already a 20-hour work expectation and an 8-hour school day on your plate. So we have to be very, very insightful how we do this. But here's the thing. Here is the thing. Kids don't need us like they used to. The need is actually higher than ever before. However, there are resources and people available where the idea that we have to be the all knowing expert of everything as a classroom teacher is no longer your expectation. I mean, for example, take a look here at Ryan. In 2018, he was the top YouTube earner. He made, a small $22 million fortune. And not only that, but Ryan has done amazing things. He's a first grader. He's got millions of followers. He already has toy line. He has a toy line with Amazon. He has a toy line here with Walmart. He's got things happening. You can go buy his products. And what does he actually do? He unboxes toys. Now you might be thinking like, so why are you sharing this with me? I'm here for computer science. This kid and his family, whoever his team is using analytics and data and computer science to deploy to figure out how to continue to be successful on this platform. And these are a first grader. These are kids that are doing things that we never thought was possible when we were kids, let alone many of us don't even think we can do it now as adults. Guys, the world is happening, it's moving, it's shifting so quickly. Tools are available and we have to be prepared. So, why computer science? Outside of one anecdotal story of a young kid that's making way more money you'll make in a lifetime and it kind of makes you angry. One, workforce development. The job market's growing. People are looking for ways to infuse computer science and they have to have people that know how to do it. the economic opportunity, not just for you as a personal, for job employment, but for society as a whole. We have lots of problems in the world that have solutions that are going to require computer science. The creative and artistic expression is something that I don't think gets enough attention. The beautiful artistic aesthetic eye that's needed for computer science is more important than ever before. How do we take these ideas, the data, the numbers, the coding, the logic, all this stuff, and make it aesthetically appealing to the user, to the human? It builds grit. If you ever tried to write code, and computer science is more than code, and it doesn't work for the 80th time, we're building grit. And the problem solving skills, which we know you can pull up any kind of study, this is what people are looking for more than ever before, are people that are able to solve problems. So it comes back to this of what do we imagine for the future? And I love this quote. You've probably have seen it. I use it all the time myself. But the illiterate of the 21st century are not those who cannot read and write, but those who cannot learn, unlearn, and relearn. This is what we're after today as educators. We're going to have to do some learning. We're going to have to unlearn some things about ourselves, and we're going to have to relearn. We're going to have to relearn how to infuse computer science into literacy, into social studies, into math, and all our subject areas. We're going to have to learn exactly what in the world is computer science. And we're going to have to unlearn some things that maybe we thought were really, really good that maybe we need to reshift a little bit. And it comes back to this personal why for all of us when we got into education. Why did you get an education? Let's spend a minute of private reasoning time to just remember why we decided to become an educator, because that why is instrumental in everything that you're about to do. We can't lose sight of the why. And I know for me and for others over time, you kind of get beat up, you kind of get dented a little bit in your arm, or you kind of get tangled up in negativity and maybe toxic cultures, and we can lose our why. And we just need to take some time to remember what it is. So, now that we remember our why, we need to think about perception and the things that are around us, because computer science is everywhere, right? It's kind of like this passage here. There's so much computer science happening around us the day to day, every second, that we don't even realize it's happening. It's just so obviously around us that it becomes almost mysteriously invisible. And so we know this stuff comes from code.org, that computers and software are changing everything. Every day there's something in the headlines, whether good or bad, about this. But the majority of schools, we're not teaching it. And these stats may be adjusted a little bit here over the course of a year since these last came out. But we need more computer science. That's why you're here, to learn more about how to do this. A lot of people, when they think computer science, they're thinking that students should learn to code. And actually, that's not the whole case. Coding is just one element, one aspect of computer science. So people would say, "Why do our code during our code week? I'm doing computer science." That's not enough. It's not good enough. It's not good enough. We need to be teaching computer science. So what does that actually look like? It's not just about technology. It's not just keyboarding and how to use PowerPoint and how to log into a computer. But computer science is logic. It's problem solving. It's creativity. We have to understand algorithms, how apps work, how the internet works. And if we don't start to understand how these things work, then we, the human, become the product. And that can't happen. We have to be aware of what's happening around us. We already know that many people want computer science to be available in the schools. People see the need for it. They may not understand it, but they know that there's a need for it. And we also know that computer science and the jobs are the source of new wages, the money rolling into this, the new job fields, the creation, as well as just steady, good, middle class income in computer science is there. And there's more and more of these jobs popping up as more industries start to realize how much they need. And I don't like to share this, but I know this is important for a lot of people. I'm not passionate about computer science because there's more money to be made. I think that's the wrong mindset. But it's also the reality. And in your community and to your board members and to the people at large, this might be very important. So I'm sharing this for you to have for those conversations. However, I don't believe that we're doing, I don't believe that we're teaching computer science so that people can make money. That's not why we're doing it. And here's a map of computer science standards across the nation. Now, this probably needs to be updated, as I'm sure there have been other states that have adapted standards since this. But the idea being here that we've got a long way to go in the US, and other countries are already surging forward. And if you're not aware of it, the United States, the White House, the executive office has put together this 5 year course of the strategy for STEM education. And in this plan, computer science is mentioned several times. And so, if you're not aware of this 5 year plan of what the White House has laid out, and you're not aware of how the computer science falls into that, you need to spend some time diving into this, because this is what the nation's expectations are. And this is important. And I'm finding lots of people aren't even aware that this is even available, that it was even published here within the last year. In this plan, even though it focuses on STEM, but computer science is part of that. The threefold goal is that every American masters basic STEM skills, and computational thinking is part of that element. We need to increase access to STEM among our underserved populations, and we need to encourage students to pursue STEM careers. This requires mindset and confidence development more than anything else. So how do we do that? We start with the K-12 computer science framework. And if you're not familiar with this, you need to check it out. It's a robust document. It's huge. It's 300 plus pages, but it has everything in it that you would need to help kind of figure out how to lay out computer science from a K-12 perspective. And what it is just this. This is the vision of the framework to help give you what you need to have the conversations around computer science, to develop the knowledge and the artifacts of how this looks within your school, within your district, to help people understand the role of computing in the world around them, and then to express those skills and those thought processes in other subjects and interest. And the principles behind it are pretty straightforward. We need to get more participation. We need to figure out just on what's essential. We can't dive into every element of computer science. There's not enough time in the day. Not reinventing the wheel. What's already been created, what's already been established, what are the already things happening in schools that are great, and how can we strengthen those? Once again, taking a look at the research of what's needed and what's not, aligning it to the nationally recognized frameworks, and then inspiring the implementation to actually make it happen. So the framework has what's called concepts and practices, and these are the things that we're going after. The core concepts of computer science is we're looking at computing systems, the networks and the internet, data and analytics, algorithms and programming, and impact of computing. Now there you're going to see that coding is one piece, one puzzle piece, not everything. And I think we need to remember that. And the way that we get at those concepts are using these practices that you see down below: an inclusive culture, collaboration, creating the artifacts, recognizing and defining the problems, testing and refining our artifacts, communication, and then using abstractions. So this whole thing, you're going to start to see like, man, that kind of sounds like science. Yeah, it is. Kind of like a science experiment. Same kind of stuff you're using in math. The way we should be evaluating what's happened in the history in social studies and helping to create solutions to future problems. What I like about the framework, it also then creates pathways. So it's going to help you very generically, because every school is so different and diverse, but it helps you based on what your goals are, how you can start to map this out in a K-12 system for your district or school. And it even talks about early childhood. And what I love about the early childhood piece, the reason I include this in here is because it's all about play. We're not putting kids in front of devices. We're getting them hands on. We're linking in the emotional learning. We're just setting the stage. We're planting the seed for what could be down the road as they start to get further and further down the pathways of computer science. So you have the framework. And then you have the CSTA standards. These are the standards of what students need to learn and know how to do in the computer science. So the framework helps you develop everything. The standards are actually then the content. And then you could take it a step further, and ISTE has these computational thinking competencies, and these are designs for teachers. And these are the skills and the knowledge that a teacher would need to learn and develop and nurture and grow to be able to use computer science to teach it and to help put it into action in their classrooms. So you have the framework, which is huge. You have the standards for the students, and then you could use the ISTE computational thinking competencies to strengthen the mindset, the confidence, and skills and knowledge of your teachers. So if we look at Iowa, that's just where I'm from, we can see it in this once again, it probably needs to be updated. The amount of jobs that are currently available in Iowa and things that are needed just around computer science. And you can do this for any state on code.org. With anything right now, we know how important equity is, and we need to make sure that we're aware of that. And there's all sorts of stats out there, but the numbers are dropping for women and our minorities and everybody else. And we need to make sure that we're creating platforms in our schools, allowing everybody to have an opportunity to explore computer science. So I know for me, where I live in computer science, a lot of the opportunities are after school or in evenings, which is great if you have a vehicle and you don't have parents working second shift and you have the money to pay for these courses. This is why it needs to be in school so everybody has an opportunity. Things are changing. So let me ask you this. How many of you refused to put a credit card into a machine 15 years ago? Most of us believe in cold hard cash. We didn't even like ATMs. We went to the grocery store. We wrote out a check in the checkbook. We weren't swiping credit cards. We didn't trust these machines, these robotic elements with our money. Things have changed. I always like to talk about my father, a third degree black belt, martial artist, traveled all over doing stick fighting and weapon fighting and demos and all this kind of good stuff. And now I get text messages of him sending me poop emojis. A world that I never thought would happen, that my father, this kind of Chuck Norris tough guy, would be sending me poop emojis. The world is changing. We're adapting. Things are moving on. This used to be our world, waiting for the dial-up, the AOL. You've heard the sounds and the symbols, and people have used those in their talks. And now we have kids freaking out because Netflix doesn't load in 5 seconds, right? So I think we need to think about it in this context, that our students are going to be asked to solve problems that our schools have never thought of or have never been included in the classroom before. This is really powerful. Think on that. And so, what are we doing to give them the skills and knowledges available and needed to be developed so that they can find solutions to these? Whether we like it or not, science fiction has become a reality. Science fiction is all our students know. My daughter has an iPad with Minecraft and the computer with Minecraft. She can watch videos and tutorials, and she can go and demo and do, and she can take pictures. Like, this is crazy to me that her whole world of touchscreens and multi-screens is just the norm. She doesn't think twice about it. Wasn't that long ago, and maybe it's still current for many of us, that we were freaking out of humans texting humans, and we were worried that text messaging was taking away. Kids don't know how to communicate. They don't know how to talk. They don't know how to look people in the eye. But to me, this is almost a bygone era, because now we have robots with personalities, and we have bilingual students. We have students that don't even speak their native tongue, but they also know how to speak machine, because the AI is not super intelligent yet. So humans now are learning to speak machine. My kids in the mornings have more conversations with their Alexa than they do me, asking the weather and the time and the alarms and the music and this and that. And things are changing rapidly. If you want to be a writer, you want to do writing, whether you're going to be an editor for a newspaper or a magazine or writing a book, you better know some computer science. Your web development tools are pretty important. Your HTML, your CSS, how to read the analytics to find out who's reading your work, and how to network and develop and push to different platforms. In the medical field, it's not just knowing how to use the tools for surgery and understanding, the different elements of the body, but what about cochlear implants, for example, that require someone to write code for them to work? Or what about in the medical field and computer science in terms of 3D printed body parts, that they're trying to figure out how to print body parts so we can travel further and further out in space? Or maybe you've seen this several months back, but the CRISPR babies, how you're able to use CRISPR for the babies. Unethical, but happening. It's real, and it's been done. What about the CS? And you have a Roomba or a iRobot that cleans your floors, and don't think for 2 seconds that they're not storing every single element of your house, sending that data somewhere to be manipulated. Your Facebook ads, everything else. Are you a product, or is this the product? And things are moving everywhere. Computer science, we're finding it in our house appliances. We're finding it in our trash collection. These trucks now have more computer science and tech into them than we've ever thought. And in jobs that maybe we don't always think about computer science. And so now as they start to weave more of AI and these different things into the trucks with the cameras and the joysticks, the biggest injury to trash collection people now are this carpal tunnel syndrome using the joysticks. That is insane to me. Or in the Midwest in Iowa, where we love John Deere, there's a startup's going to get driverless tractors. Think about the computer science needed for a tractor to understand the terrain, the crops, the hills, elevation, weather, everything else in order to properly harvest crops. And this climate assessment report just came out by the National Climate Assessment, and things are happening. And if you haven't looked at this report, here's your next projects for your kids to solve. Agriculture is huge, especially where I live in the Midwest, and so you can find this information depending on where you live. But as we start to see changes in weather and the impacts on our crops, we need more technology to help us adapt to keep the food supply and crops going for everyone. And then, more importantly, we have the UN Sustainable Development Goals. These are 17 goals separated by the UN to be solved in the year 2030. So we look at poverty and we look at hunger, we look at sanitation and life below water and climate action and all these to be done. Computer science plays a role in every single one of these. And so we can start to look at the stats, the figures, the projects, starting to dive in and infuse that into these interdisciplinary projects that are going to be weaving in our science and our literacy and our math and our social studies and our global perspectives and computer science. And you can just read the headlines of the papers every single day, and you're going to see something. Jobs being cut, jobs being developed, new jobs happening, this robot, that, this, there. We need to start paying attention to the things that are developing around us. And finally, what we have are the 7 big computer science ideas. And these are the things that are floating around that we need to start to wrap our head around when it comes to computer science. So, something to make very clear for all of you as we start to think about this: computer science is not just coding, and it's not STEM. And these often get all mushed together into one concept. Computer science is understanding the architecture of computers, the networks, the software, the engineering, how data is being used and stored and manipulated, the program design and programming. It's not digital literacy, it's not STEM education, and it's not just hour of code. And because of the demand and because of the need and the urgency to start to infuse computer science, there are so many options out there. It's overwhelming. If you go to ISTE or any major conference, it's everywhere. The whole entire floor of, of the exhibit hall almost looks like a playground in makerspace and STEM and computer science. So we need to be careful of what we're looking at to make sure that we do have the equity and includes everyone and it's of quality. And so it's going to be really important. So as we kind of wrap this up, we need to think about this quote from Seymour Papert from 30 years ago, and it's still true today. As many of you are working in environments of one-to-one devices or carts or your cows, computers on wheels, whatever it is that you're using, right? Are students programming the computer, or is the computer programming the student? And I think we need to start to think about the shift because from what I've seen, almost every school we have the computer programming the student. It's the computer telling the kid what lesson to do. It's the computer running the software for personalization that says you're here. The kid is not in charge, and we need the kid to be in charge. And we do that through computer science. So in Iowa, and if you're presenting this, we need to figure this out for the local flavor of the state. So this is my non-presentation voice here. We have lots of opportunities. There's a computer science incentive fund. We've got money being pumped into computer science for teachers to get trained and educated. There's workshops, there's trainings, the Department of Education. So we need to find out what's happening along in the local area because a lot of times as teachers we don't have time to do it, but these things are available. And with that, it's time to dive in to actually then the strategy behind computer science, the strategy behind how do we begin to infuse it. And so this is what we're going to dive into next. But before we do, let's open up. What are your thoughts? What are your concerns? What are questions? What are ideas that spark conversation so that we can have some conversation around that before we dive into not just Minecraft, not just computer science, but actually how to make all this practical for you in the classroom.